All right, for the past almost 2 hours, it's been somewhat entertaining, and we were talking about a lot of fluff, as you might think. And now we're going to go down deep into the essence of a C language. So in embedded security, if you just have a static analysis tool, let's just say all you have to inspect is the code, right? And then the embedded device operates, let's say, via the Bluetooth. It maybe is even hanging off some sort of a Ethernet connection. Maybe you have some other forms of communication to the device, right? So if you're just looking at the code, what can you realistically say about security? That's actually a question that is not easily answerable unless you really know C. So let's just go maybe some ideas. What can you look? What can you detect at the code level with respect to security? What are the chances? Yes? Buffer overflow, yeah, memory protection, yes. So if everybody knows what buffer overflow is, so if you're reading, let's say, a buffer outside of the defined space, then you may get to the areas that are not, or some other data which is not part of that buffer, basically. Buffer overflow is one of the classic examples. Sometimes people say, oh, I've just tested my device for memory leaks. Well, you also tested for security vulnerabilities at the same time. So safety and security in this case overlaps. Yes, one example. Another example, yes. Yes, type conversions, integer overflows. Type conversion is different, but yes, casting. It's good, but not for embedded. Not for embedded. At least I haven't seen the embedded device yet. Maybe I'm just not exposed to that. That would actually process the passwords that are sending. There are keys, right? There are some security keys that are stored inside the device, yes. But normally users on the edge devices like sensors and some controllers, they don't normally log in. So that's pertinent for Java and C# type of domain, but not for embedded. Yes, but input validation is important. So let's say in the embedded device normally parses argv and argc arguments. I haven't seen people who would actually make use of those arguments. And most people just define the main function as without any parameters. So, all right, any other examples? Yes?
Resource management, like closing file handles or
yes, so if your embedded device has a file system, absolutely. Resource leakage. But what if embedded device has an RTOS, for example?
Well, it could also be just any resource. It could be a socket, it could be network.
Right. And I'll add to that resource management, but also multi-threading problems. What if you have a deadlock and you can do denial of service attack on the device when you force the device to have some sort of a deadlock between the threads? Okay? All right? Exhausted the list? So I looked at the CertC website, and they actually are pretty good about listing what the rules they have. So I glanced over like for 15 minutes, and I scribbled some examples that I think are valid. Unsafe macros with invalid arguments. So if you're passing some parameter to a macro that can be rolled out by the preprocessor, then if you pass, let's say, an assignment operator, it may change the macro's behavior, right? So conversion on integers, we already covered that. So if you try and typecast or an integer into a float or something, you lose the precision or gain the precision in that matter. Information leakage. This is something we haven't touched at yet in our exchange, but what does that mean, information leakage? When you have a kernel space, it's protected by hardware and operating system. When the user application run, a lot of times, safe RTOSes like Wind River VxWorks or Green Hills Integrity, they give you ability to run user application in a protected space. So when kernel calls application, we want to make sure that with that call, there's no data that is leaking from kernel space to application space. Okay? So those are all detectable, theoretically, at the static analysis level. Using data outside of declared object storage duration. So for example, if I declare static, it should only be visible within certain, let's say, file. Or if I declare a local variable, it shouldn't be accessible by, let's say, outside. So nobody should be accessing my stack while I'm running that function, right? Avoid accessing array out of bounds. We already had that one. Thank you. And that's not complete list. Stack and heap overflow. So we haven't covered that. But for example, if the program runs and it, let's say, runs out of stack or runs out of heap, then it may have some undefined behavior. Okay? So that's where we said that undefined behavior is bad, and stack and heap usage violations are considered to be not only the safety, but also the security violations. So when we call a standard library, let's say stdio or file open, file close, sometimes those libraries give us error codes, right? So if we don't check the error codes and then proceed, you can theoretically hijack the standard library and inject those errors or do something. Then if your program does not react properly, does not handle the error conditions properly, it will lead to undefined behavior, and of course it may be exploited by the attackers. Passing a non-null terminated string to a function that expects a string. That's classic, right? I don't want to spend time on this because I think everybody knows that. That's what they teach in the Hello World example. Avoid multi-threading issues. We covered that, John. It's deadlocks, priority inversions, race conditions. You don't want to have those. And those are all detectable by the static analysis tool. Yes? Or questions? Comments?
Sometimes
Yes. Most of the time not, actually. Because there are other reasons. Ensure correct pointer arithmetics. So when you're calculating the pointers, let's say if it's a 32, or let's say you've tested your code on a 64-bit processor with the x86 architecture. You compile it with GCC, and you said, oh, OK, this unit is fine, right? But your pointer arithmetics, in this case, if you did not define the types correctly, then it might operate on pointers that are pointing to a 64-bit memory space. And then when you're running at the same code on, let's say, Cortex-M3 or some other 32-bit microprocessor, then the pointer arithmetics may act differently. So that's about testing, right? Whatever. Wait. General rules to eliminate undefined. Yeah. So in general, as a catch-all, they produce the CertC coding standard, which is developed by Carnegie Mellon University in conjunction with a security emergency or computer emergency response team, basically sponsored by the American government. So it's a good standard to keep in mind when you start developing your IoT applications, because chances are you may either get in a situation where you have to prove yourself to be in a functional safety situation. That's where MISRA comes in handy. Or you have to prove to your organization that you've done everything you could to make sure that your embedded device is secure, which is in IoT space is very applicable. Okay, so just consider those standards. All right. As much as we like static analysis, people don't adopt it on an everyday basis. Like, okay, let's take a poll again. Out of 50 people in the room, how many people in their day-to-day job actually run static analysis as part of either pre-check-in or on a build server? Okay, I'm going to calculate. $16 out of 50. Okay, how many people in the room actually ran static analysis before, either as part of a class, who know what we're talking about here, as part of a class, as part of a previous day-to-day job, as maybe part of an exercise that you've done on the side? It's a majority, so I would say 80%. Okay, so the 16 people who run static analysis on a day-to-day job, what do you see, or maybe other people can chime in as well, where do you see as static analysis adoption problems in the industry? Okay, so let's talk about the adoption of that practice. Practice is good, right? It eliminates all of those defects that I outlined. Sometimes they can be caught by the code review. Sometimes people are just smart programmers. They read a lot of books. They don't make those mistakes. Yes. Static analysis as a tool is a useful tool. So, yes, John.
I was going to say, like, problems that I've run into are there's two classes that I would say. Some static analysis, not done with C, I've done it with like Java and Go. Some of them will just try to be like more about formatting, like you should format stuff differently. And which goes against how we're already formatting stuff, so like it generates a lot of noise.
Yes.
The other side is like, oh hey, we've got run static analysis and this is 10-year-old project and here's 1,500 errors.
It's very common.
Where do we drop 3 months out of everything else to fix that?
Yes. Very common. Yes, Andy.
I've actually found it to be easier to adopt when it's imposed, kind of like through the CI server. You force people to adopt it, but I've also found it really useful to train new developers because it calls out, and actually some of them will propose solutions.
Over time, as one of the consequences of running static analysis practice on a day-to-day basis, that is the result of it. People, like you hit it once, you hit it twice, and the third time you'll actually code that particular, let's say, integer conversion correctly, or that pointer arithmetics correctly. Or not correctly, but consistently. Yes?
We do it as part of our check-in. And the tool allows us to set like gates to say it has to get better. So we can run it on legacy systems and say it can't get worse, but it has to get better. And so it allows us to adopt it without saying, without having those 15 stuff.
Yeah, focus on the delta, and I'll cover that as part of best practices, yes. Focus on the delta is very common. A lot of people say, okay, we need to have what's your name? Edgar? So what Edgar is talking about, there is a problem. You have a whole bunch of legacy issues. I've seen some people run like 14,000 violations. What? So where do we find the time, 3 months in a project to kind of do it, right? To take care of them. And people just don't do it. So when they run the static analysis, now the tools or maybe scripts, whatever, can have ability to give you just the delta between what you had yesterday, what you added, and just give me like a 3 or 4 that I've introduced. I don't care about those 14,000s. So baselining is important, yeah. But now we're talking about solutions. Problems are good, right? So any other?
Yes.
I mean, so our biggest problem has been that, like, just the UI, the system, the UX of the system is pretty terrible, and it causes you a lot of delay to have to wait for, the build has to go through, and then the system takes a long time to check, and because of the licensing cost on the system, we can only have it on the CI server, so you have to have your code committed and pushed up into a PR or something like that before you can go through it. And then we find that most of the things that it pops up with aren't actually problems, and it's just something that we're battling for reasons that we don't fully understand. So
makes sense.
Yeah.
Very common. So yes, any other questions? Or I'll just go one by one. Running slow is what you're kind of saying. Okay, it's just not the workflow. False positives rate, amount of noise, huge issue that people bring in. I don't see the value in fixing the violations, very common. Too busy focusing on real issues, we're like, it's a formatting issue. What do I do? It's like, screw it. Commercial tools are expensive, open source are too noisy. That's whatever. Takes too much time to analyze the problems reported, so 14,000 violations. Where do I have time? And so those are some of the things that people are saying to us as well. I think I captured most of the concerns in the room. So practical approaches. Some of you, 16 people in a room, run it. So what I've seen, and then most of you don't. So when you start getting into the static analysis realm, that might help you with either functional safety or just a general coding improvement training. You want to create, integrate static analysis practice into the CI/CD workflow, even if it's like one rule. Even if it's like checking only for, let's say, arrays out of bounds. Only if it's checking for interesting bugs, you have to integrate it into your pipeline. So it runs periodically, so it pings people on a daily basis. Create a baseline. So if you have, let's say, 14,000 violations, move them aside and focus on a day-to-day job. You can slowly, when you get time, address some of them, but don't focus on the fact that you have lots of violations in the legacy code base. As a matter of fact, there is an argument to be made that fixing legacy code base just for the sake of cleaning up static analysis tool may introduce more defects that you're actually fixed with it. So there's I think they call it like 25% probability of introducing more defects into your code base by refactoring the code just to make static analysis tool happy. So don't do that. Start small and solidify the issues resolution workflow. So if you just add one rule, let's say start slow, get the workflow in the organizations, and then slowly add more rules as you see comfortable, as you see the workflow comfortable. Focus on deltas between the previous. Yeah, that's what I mentioned. Focus on the deltas. So whatever you checked in, let's say if you have checked in 20 files as part of, let's say, sprint, right? Just focus on the violations that you did for those 20 files, you caused for the 20 files. Integrate static analysis and suppression review with a code review workflow. That's one of the clients that we have did. They've integrated quite smartly in the code review workflow. Now they show, as part of a code review, if you suppress any of the rules, it actually shows the reviewer that not only you did some changes to the code, but you also run static analysis, and that's the list of suppressions that I consider okay. So are you, as a reviewer, consider the same suppressions valid? So that's good, right? Integrate with development workflow. I already mentioned what you said, Mr. What's your name? Patrick? So what Patrick said there is, it's a development workflow issue. It runs slow, the GUI sucks, number of licenses. So if the developers are not embracing static analysis, it's never going to work, okay? So there's a bunch of static analysis tools. You can read of them on the internet, Google them. As I mentioned, we do have Hall of Shame, our evangelist, Arthur Hicken. If you go and just type code Carmageddon, you will see a lot of the IoT-related issues that could be prevented with the use of either static analysis or. All right, enough for static analysis, moving to the unit testing. Unit testing is something that is also required by many standards, like ISO2626 as you can see here, requires you to run some unit testing. And depending on the AC level, it may be stringent or it may be very loose. Just like any other standard. I talked to a gentleman with DO178B requirements. Same thing. Depending on your classification, it may be very stringent requirement, MCDC level of code base, MCDC level of code coverage, or it may be very loose, like you have to run unit tests. And it's not very specific about what you have to do. All right, so how many people don't know what the unit testing is? I don't expect any hands. So as part of the computer science program here, or computer engineering, you probably have written a number of unit tests in some classes, or as part of your day-to-day job. So just I was thinking about, okay, who am I going to get in the class, right? So we're going to skip that one. But the unit testing in the real life, the industry adoption, so as part of my job, I go and talk to people, right, about what do they use, what do they do for unit testing. And the reality is, as much as the books, the speakers, the experts are praising unit testing is good for you, not many people do it. And why is that? Now there's a poll. Why, in your opinion, the industry adoption for unit testing is low?
It's a lot of work.
Yes, changes the coding design. It forces certain principles that might not work with how it's implemented. For example, inversion of control, you need to inject for unit testing. It's legacy code isn't designed that way. The data model is very hard to inject against. So,
what you said is the legacy. Testing legacy code that was not designed with a clean interfaces and clean data exchange between the components, we call it spaghetti code, is hard because you cannot isolate the unit under test cleanly, right? You don't have an inversion of control, or you don't have clean interfaces. So a lot of times that's hard to isolate, and it's hard even to inject the right state into the object because there's a lot of global variables, a lot of global stuff you have to create around that object because there's, yeah. Did I summarize it correctly?
well, it's not just legacy though. What you said about injection, it's forcing a design principle on whatever system that is. It's a fundamental of unit testing. If you don't have that in your system, you're now changing what the design was, saying you have to have inversion of control so I can unit test it. The designer may say that makes it more complicated, and it does. It may work without inversion of control. You can't unit test it, you can systems test it, prove that it works, but you can't unit test it.
Okay. I hop by. Yes.
Generally, companies can get away without it, so they don't.
I think that's the number one issue. You don't have to do it. And that's why it says outside of a safety critical industry. Yes. If you're not requiring doing it, yes.
And just because it's required, it doesn't mean that everything's unit test. If you have one unit test, you met that requirement, and therefore, even in that safety critical system, you're
Yeah, safety critical system has standards. So it's very kind of binary there. You either comply with whatever you said you're going to do, and you can show that for every, let's say, unit in your design, right, you have some sort of unit test. You have to show the data. Unfortunately, that's the case. Yes, any others? All right, so let's speed up. That's some of the things that I've collected over the years. Unit testing is useless. It doesn't find the real issues. And it's true. In some respect, if you're looking for synchronization issues, and then you're trying to apply unit tests to find certain bugs of synchronization domain or some sort of a communication domain, you won't find those bugs in unit testing. However, those are the hard to find bugs. So you have to focus on that. But unit testing doesn't find them, and you have to be aware of it. I don't have time to create, maintain, so you can read this slide. But basically, I agree with everything except maybe the point that you made that it changes the design. I would argue that it's maybe a good thing for you to change the design to have clean interfaces, but that's just me.
But it's still an argument that some people make. Yes.
Yeah. Yes, true. Yeah, so I wasn't asking for good arguments, right? So, thank you. Yeah, you're right. So everybody agrees, though, on one topic. The process of creating unit tests is beneficial by itself. So when you just develop your code, and then you need to unit test, you naturally put a different lenses in your design, and that produces value. So it's like an automatic code review for you. Once you start creating unit tests, you're thinking about what are the inputs to my function? What are the outputs do I expect? What happens if, let's say, this gets returned? So you're like, I need to put the error logic there. So as you develop the unit test, your design, your code becomes better naturally. And then you can throw the unit test away. So, yes? Nah, I say it's all. Sometimes when I did not do thorough TDD when I was coding. What we did is we wrote the unit and then we created a unit test for it. But even then, I find if I do it before I give it to formal review, if I do the unit testing of my code, it still provided value to me because I find even better ways to implement it sometimes by decoupling certain components into more testable objects. Oh yeah. I was always going back and forth between the unit test and the design until I kind of was happy with what I see, right? All right, the most important topic out on this is highlighted there, is deciding on the boundaries of a unit. That's like a religious discussion in all of the rooms I've been at. What is the definition of a unit? If you open up a book and you read the definition, it says the lowest level that the program can operate on. So it's a function or it's a method, right? It was true, in my opinion, a long time ago. I would argue that it's no longer true. Yes, there are some functions that are big, and you might want to test this function in isolation, or you may have a requirement to test every function. But the beneficial thing for you is think about what is the unit that you're testing. Maybe it's a thread, right? Maybe it's something that is 2-3 modules put together, and you call that a unit. So when you start deciding, hey, I'm going to be unit testing, maybe think about what is your definition of a unit. Because then you can start creating meaningful tests. The result of that discussion that you will have with your peers and with yourself may be even the traceability aspects that I covered here. So the traceability. When you start tracing your requirements to lower level design components, for example, to requirement to code, it's much easier to decompose the requirement to something bigger than something smaller. Because the requirements are normally written in a high-level language. Okay, the device shall do this, this, and that. And your unit is taking integer and getting you integer. So how do you match the domain-specific language with something like with a function call? Well, if you start combining units together, maybe that chunk of code produces something meaningful to the domain language. Let's say processes an event in a system and generates like 5 more events. So if you focus on the interface and definition of a unit, your life will become a lot better in general and easier. So key takeaway from here. When you say unit testing, the first thing you should question the person, what is the definition of a unit, and have that discussion. Okay? Now, next discussion, host versus target. Do you know, do anybody, who does not, well, how would I phrase it? Okay, let me just read this. There are two ways in the embedded world, there are two ways to run unit tests. One is on the host, that you can compile your design, compile your code that's supposed to run, let's say, on some sort of a board. You can compile it, if you do certain things, with a host compiler, meaning GCC, Microsoft Visual Studio, some compiler that produces you the executable that you cannot execute on your target anymore, but you can execute it on a host. That's called the host unit testing. The opposite of that is the target unit testing, where you compile your code with a cross compiler, link it the way it is, load it up with the debugger to the target, and then execute it there and get the results from the target. That's called the target unit testing. Okay? And now the industry fluctuates between the two. Okay, do we need to run unit testing on a host, on a target? There are a lot of discussions about that. How does that relate to IoT? The relevance of this conversation as relates to IoT is twofold. First is preparing yourself for functional safety audit. Second is prepare yourself for CI/CD integration. So in IoT, it becomes more and more important to integrate your deliverables into the overall delivery pipeline. Let's say you check in the code, something should automatically run. Something should automatically trigger, run static analysis, run a unit test or some unit tests. The problem with a target unit testing right now is when you check in the code, potentially there is a Jenkins job or whatnot that is running on the Docker image that, let's say, being spun off in the cloud on God knows which machine. That God knows which machine may not necessarily have a connection to your target that is sitting in your basement. So that's a problem that is easier to execute host unit tests in the CI/CD pipeline. That's the relevance to IoT space. Okay? So option one on this screen is we compile with the host compiler, and we're going to do host unit testing. Pros, you can execute fast. It's easier integration with the CI/CD pipeline and an easier setup in some cases. Not in all, but in some cases, I can claim that it's easier to set up. The cons of it, it requires you to stub your hardware level hardware driver layer, because a lot of the drivers potentially may be compiled with some pragmas of a, now I don't know if I'm making sense here when I say it, but some of you will understand what I'm talking about. So some drivers have some constructs there that may not necessarily be compiled or liked by the host compiler. I'm getting into the parts of the talk where only kind of few of you will understand. So pragmas, there are all of those things that are specific to the target compiler, cross compiler, has to be linked out. So you provide those stubs requiring stubbing of the hardware driver. So you have to stub them out. So you have to do something in order to make the host unit testing work. Different compiler and architecture. Well, if you run your unit tests on a host, and I come in a courtroom and ask you, have you executed all of the unit tests in the environment close to the target as possible? You cannot answer that question because your unit has been translated and compiled for the different architectures. So your memory layout, your pointers, your types, they're all being interpreted by a different compiler and being put in a different binary. So the fact that you're running it is great, but it's not the final product. So building a safety case in this case is a lot harder, okay? And need to maintain multiple projects. So let's say you have a makefile. It runs really well with ARMCC or some IRCC, whatever, some cross-compiler. It's great. Now you have to create another makefile that will run your unit tests. So now you have to maintain two makefiles. We all know that maintaining build infrastructure is a pain in the butt. Now you doubled it. Yes.
Emulators, right? I mean, the amount of service that provide emulators. Don't we just go ahead?
Don't jump forward. You're ruining my show. Yes, but yeah, that's an answer. So option two is running on target. Again, pros and cons. Testing is more realistic, easier to build your safety case, but you can actually test hardware drivers. There's some intricacies of putting the hardware in the loop, or we call it HIL testing, hardware in the loop. So some of the standards require HIL testing as part of the deliverable. With unit testing, you can make an argument, but it's harder. But anyway, so you can test hardware drivers because you are testing on this hardware. The drivers will, the hardware may, let's say, issue some interrupt or may raise some signals, or hardware may actually react on your register reads and writes. But in unit testing, that's not the point to test hardware in the loop, right? Again, the definition of a unit. Maybe the unit test is the fact, yeah, you write registers, so you ignore the writes and reads. Or maybe you write a little thin layer around the registers, maybe a function calls, just inline functions that we're getting to the discussion we had. So if you have inline functions, just as a wrapper around the register write and read, then you can tell, then you can actually test it in isolation because you just stub out the functions. And there is no runtime overhead because you're inlining them. A compiler will get rid of them anyway. Make sense? OK. Cons of the target unit testing is this little thing. It's harder or impossible to run on the CI/CD pipeline. I've been at one of our clients. They are biggest retail shop on the planet right now. Mike will be very familiar with that. So they told me, it's like, I don't know where my code is going to be compiled and run. You just say run, and it finds a machine somewhere in the cloud at random and builds your code there. So how can I even connect to my target on it if it doesn't have TCP/IP connection? You have to physically connect the machine with some JTAG or JLink probe, right? So it's impossible. Problem. The solution, ta-da. We recommend, I think that it's easier to run unit tests on a simulator. There's a number of simulators that are now available. It's a Kumu, Fast Models, Kyle has one, VxWorks has one, Green Hill. So a lot of the manufacturers now create a CPU simulators. So it's instruction set simulator, basically. Some of you kind of probably already lost me, so please stay with me. The problem with simulators that many people see is that I have to validate that environment. So when you run the tests on a certain environment, you then have to say, yep, that environment was valid for intended use. Well, with the simulator, it's not the same as target. The hardware is not the same. It's been configured differently. Yes, the CPU is the same. The model that fetches the instructions that actually executes my test is absolutely the same. The instructions are being fetched and executed properly with respect to the CPU domain. But there is no specific sensors connected or no hardware components that are on the simulator. So the recommendation is create the unit tests and run them every day on a simulator. But then at the end of the project, you can run them on a host, on an actual target, as part of a formal run. So you get the best of the two worlds, exactly what you said. And there's Kumu simulator. It's open source. It's available. So I actually have a project with a little board that I carry with me to run my unit tests on a Kumu simulator without the board. So I take the board away, I throw it, and say, OK, now we can run it on the simulator. Everybody is amazed. And I don't know why people don't use it every day like crazy.
Do you see any use right now with kind of a hybrid system where they're running fast tests with the simulator and queuing up longer tests against RS at night?
Yes. That's a pattern. Absolutely. OK?
Whew. Code coverage. Code coverage has a story. And the story of code coverage is that once you take functional safety standards, the 0178B or ISO 2626 6234, they dictate you a certain level of code coverage. There are different types of code coverages that you can collect. Long story short, you don't have to worry about code coverage if you're not in functional safety. You do have to worry about code coverage if you are. But a lot of people, they want to see, OK, how well am I covering my code with my testing? Well, it's a nice exercise. You can do it. But you do it at the line coverage or maybe a statement level coverage. There is absolutely no point to get the MCDC level of code coverage if you're not inside the functional safety regulatory zone. So the reason I brought it up is because when you start doing unit tests, one of the reasons people do want to do unit tests is to show that we have 100% code coverage. Because when you start doing system-level testing, it's a lot harder to exercise all of your code with entirety of a system-level tests. So to just prove the point that, yep, I exercised every single line of code in my design, you do unit tests and you collect some level of code coverage. Yes? What is MCD? It's modified condition decision coverage, modified condition decision coverage. It is, so if you have an if statement with many conditions in it, you have to get inside that if statement with all permutations of those if statements. So let's say we have 5 conditions inside the if statement. And then every one of them, so in order to get inside the if, the entire thing has to be true. So you have to first ping that one caused me to go inside the if. Then this one caused me to go inside the if. So you set up, it's very intricate code coverage metric. So it's a condition that we are checking if that condition was flipped to true or false, and that true or false caused me, only that true or false caused me to go inside the if statement. Make sense? Okay. Woohoo! Stubs. We didn't talk about stubs, but it's important. Once you start, not many people use stubbing framework like Gmach or CMach to isolate the components under test, but it's a good thing. So you should consider using some sort of a mocking approach. One of the reasons people use stubbing and mocking to increase the code coverage. So for example, what I'm showing you right now is there's a red line that hasn't been covered. So how do you get inside that if statement there? Is you need to kind of fake that strlen will then be equal, the output of the strlen will be equal to f right. The easiest way to do it, instead of just creating all the conditions to satisfy that, the easiest way to just stub them out and fake the return values. Okay? So stubs are useful to drive.
So would your earlier example of the kind of the API that's not actually connected to the car be like a mock system to simulate how people would call it eventually? Or?
Could you repeat?
So you originally talked about an API simulator that simulated returns that you would get when you hit the API and go to the car. Would that be considered a mock for the connected car, or would it?
No.
Not really? Okay.
No. We'll get there. Okay, if you still have that question at the end of the talk, come talk to me. But no, it's not the same. It is, I would call it not an API mock. I would call it API service mock, but it's not the same as this guy. This guy is at the function level, stub. That one is at the API level. It's different notion. You can call it a mock in some universe, but I wouldn't. All right, unit testing, popular frameworks and tools, Google Test, Unity, CPPU Test, Boost. So all of those things, you might have seen them. I didn't list them all. Most people either use one of those or they create something custom. I see a lot of people who, we've created our custom unit testing framework. Well, good for you. And of course, there are some tools that for use for functional safety. We are one of them. As a summary, to bring the first part of the talk to conclusion, you have to identify potential risks and your potential safety integrity level. Another trick that people do is identifying some modules and really isolating them by build or putting them in the libraries, right? That can be then classified as safety critical libraries. So when you think about the architectural layout of your system at the design level, think about which parts of the system you'd like to isolate so that if you have to verify them and qualify them for safety critical, you have to build the compliance case for that particular piece. It's not touching other pieces. It's just, let's say, a file or a library or something isolated. So think about that. Establish full coding standards, run static analysis. Running on a simulator, unit testing on a simulator, that's your friend, in my opinion. So, but when you start thinking about your IoT testing, establish little things. Like make sure that you're running static analysis tool, at least with one rule. make sure that you have at least one unit test that you're running. Once you establish that ecosystem, the build ecosystem, the workflow ecosystem, the fact that you're running just one unit test, so to go from one unit test to 100 unit tests, you can potentially hire, I don't know, 30 contractors to do that. So that's easy. It's harder to put it in a workflow. Okay? Done. Oh, any questions there? We're wrapping that topic up. Okay? Switching topics. Now we'll not talk about compilers, linkers, simulators, MISRA, unit testing. We're going to forget all of it. We're going to move to the wonderful place of API testing. You already seen that. So IoT communication stack is almost the same as you would think in a normal IT communication stack. There is only one like the Zigbee protocol that is spanning across various levels. The ones that are in my picture that I will be focusing on is this HTTP, application layer protocol, MMQTT. They have slightly different characteristics to it that may or may not be pertinent to how you test your component in isolation. Okay? Back to my example. Now we kind of verified all of the components in isolation. We ran static analysis. We created unit testing code base. We know the code coverage. Then what? Then you want to verify this piece in isolation. So you would inject CAN events into the bus and see how the sensors react. Or you want to sit on the outside and inject the data from, let's say, fake hardware components somehow. Let's say the data if you read the registers, it's a little harder, but you can build a system with fake registers. For example, you can link in your stubs as part of the. You pretend that there is a hardware there. So you create some sort of a component inside your build that will fake the hardware at certain times. Let's say at the startup, it waits 20 milliseconds, and then boom, boom, something happens. So you can create stubs like that, link them with your project, and then create the environment that way. I promise that I'm not going to be talking about linking, but I lied. So that's how we would verify this piece, right? Then we would go and verify that component. That component is, the API to that component is MQTT and REST. Then we're going to verify the entire car. So the rules of the game there now is, again, divide and conquer. You divide your ecosystem into various components and then build a test environment around them and then test them in isolation. But you focus on the API testing. And you can verify it even that way, okay? Where you include car and other cars as part of your testing bubble or testing scope. Now, I mentioned that we will be focusing on two protocols, REST via HTTP and MQTT. So REST APIs are normally synchronous APIs. So you would have a client. It reaches out to the server, does, post, get, whatever, and then it fetches some data. Very simple, synchronous protocol. MQTT, on the other hand, has a different notation. MQTT is a pub-sub protocol where you have topics and where you can publish into the topic and subscribers, all of the subscribers will get an education from the broker that I got something, right? So it's a different notational protocol. So when you do API testing, you have to be aware of, and I'm sure you are aware, what is the notion of my API that I'm testing? Now, we are in a CI/CD world again, so I just want to point out where we at in the journey. And why did I color this in red? When we are operating in this stage, when we are talking about integration testing and system-level testing, there's one key thing that comes as a hurdle, as a challenge to many organizations, is this red thing is a test environment access. So some of you who work in IT organizations probably may relate to that challenge. When I need to test something at the system level or at the component level, I don't have that dependency. I don't have that database correctly provisioned. I don't have that third-party API available at this time, or the team who is developing some other API is not yet ready. So I'm sitting there waiting or creating some sort of hodgepodge mock to respond properly for my integration testing, right? That's the state of the art right now. That's why it's hard to test at the middle level. Remember that the testing pyramid? The biggest bang for the buck that you can get is from the middle layer testing. So if you start testing components in isolation, it, in my opinion, will give you the biggest bang for the buck, because then once you integrate them together, you'll reduce the time that takes to debug the entire chain, because you already flushed out all of the logical bugs inside them. Okay? All right, so we are there. Challenge, how to isolate application under test. The answer is divide and conquer. Okay, very simple. We will be, I'll introduce the concept of virtual services. You can think of it as a mock. You can think of it as a virtual stub, and it's similar to stubs in the unit testing. Similar and not. So what are the virtual services? It's a lightweight responder. Think of it as not the service. So there's nothing I'm provisioning on my application server. There's nothing I'm actually deploying anywhere. It is just something that can respond to my request, look at the request, look at the message format, extracts certain things from the message payload, and then, based on the logic, simple logic inside my responder, it can generate me a response. That's what it is. The properties of those virtual services are that they're easily deployable on the Docker, right? They're easily updatable. You don't have the entire database in the back end to manage the data. The data is right there. They are very useful in the integration testing domain. Lots of people use them today without realizing. You create your mocks, JMock, or some other frameworks that exist. There's a wire mock. There's a whole bunch of things there, open source. I forgot what they are now. But basically, people do that. So it's a very common approach to testing. There's nothing new. How does that relate to IoT? The only relevance to IoT that I can think of is the fact that now CI/CD pipeline is a lot more important because a lot more players out there, so you have to constantly test. And there are a lot more APIs that you have to virtualize or you have to test against. So we have more APIs, we have more components, CI/CD is more important. That's the only kind of relevance. People have been doing that for many years. Okay, any questions here? I kind of went very fast in the interest of time because we spent too much time talking in the beginning, which I like. All right, any questions here? All right, so let's speed up. All right, IoT is increasing complexity of testing requirements. So because of the explosion of the types of APIs, the types of communication paradigms, synchronous, asynchronous, now we have mobile device, we have some cloud device, we potentially have even the web interface into our ecosystem. All of those things have to be tested at the API level. So we have tools, right? We have Appium for mobile, we have Selenium for the web testing, we've got SOAP UIs, REST, what is it? Postman, yes, thank you. I was looking for a Postman, yes. So we have Postman, we have curl. We've got tools to inject things at the API level. There's no shortage of them. But for every API, you have a different tool. So the challenge that people have today is that you have to create a scenario test, inject something in the mobile, and see what happens on the other end, right? So you have that heterogeneous model where you have to start testing. But once you start testing that heterogeneously, without focusing on the API, but creating a sequence of events that are being injected at different points in your IoT ecosystem, you get problems on the back end. For example, if I'm a QA person and I'd like to test, I need a test environment. So I need either the third-party system provisioned, or I have to put that particular backend service into the state in which my sequence of events would make sense, right? So agile roadblocks. So some teams are running faster than others. So if my team is way ahead of the game, I got the best developers, I got the easiest job possible by creating things from scratch, then I'm a lot further than the people who have to deal with the legacy stuff. And I'm waiting for them to give me the access to the API. So it's also a roadblock that is very common. Unable to shift left performance testing. So that's another one, right? If I'm going to blast Google API with my performance test scenarios, Google will not like it, and they will block my IP. So when you start running performance tests against somebody else's API, they don't like it. They actually put blocks on it. So performance testing is another key aspect of IoT ecosystem, because nobody likes slow devices. Like mine is pretty responsible, or is pretty responsive. So people want the responsiveness of the entire ecosystem. More sometimes that they prefer security. So that is. Okay, good. All right, so that's where virtual services are useful. You stand up the virtual service, you provision it with enough response logic to get you through your use case, and you provision them so that you get your testing done. Of course, as a result of it, you now have to deal with a complex problem of managing the test data. Test data, once you start generating the test data, which is you injecting events and then testing it on the back end against some fake systems, then you need to manage the change. So for example, if the APIs on the back end changed, I have to change not only the test data, but the definitions of those virtual services. So there's some management that is associated with that benefit. So you get the benefit to isolate your application under test. Nice, but the consequence of that have to manage the test data. The good news is that the smaller you get, the lower complexity that you embed in those virtual services, the less of a test data management hassle you have. The worst thing to do is to actually test against real backend dependencies and running against your production data, which is probably the best from a testing perspective, but what about privacy, right? What about copying that production data into some lower level environment and then maintaining that data? It requires a lot of test data management. But the production data, normal testers only use very small subset of the production data, right? So you don't need the entire production database to test. So you only need a small little chunk for your testing. So decoupling the backend dependencies into the smaller chunks allows you to reduce the test data management aspect to a manageable sort of piece that you can check in the test data into a CI/CD pipeline. You can then check it out, run it on Docker, let's say stand up a Docker container, and then do your continuous testing. Yes?
So that works for functional testing. That doesn't work for performance testing.
It works beautifully for performance testing.
Not if you also really need to have performance testing that involves those third-party services.
Yes.
Because if my service goes down because my third-party service can't handle my load either, then my performance testing is bunk.
Okay, counter argument. You have to define your boundaries of your testing. So you define SLAs for just this application and test this application in isolation against the SLA. And then you detach your virtual services. Now you know that this application responds within certain timing requirements. You know that this is stable. Now you include the larger scope. So I would say that is practical. What you're saying is the larger scope, it's not applicable, I agree. But you divide and conquer.
Yeah, I'm thinking about it like, for reference, I work at Target for another week. And like, we're starting up our performance testing of our, Target.com and like everything else involved because of Black Friday coming up. Like the SLA is Target.com doesn't go down during Black Friday. That's the SLA.
Good luck with that.
And that stress tests what we have deployed in public cloud.
Right.
And like, yeah, we have to work very closely with our cloud provider so they don't shut us off during performance testing. But it's, the business can say like, well, I don't care about that SLA on that component. I care about the SLA on the entire product.
It's a valid point. However, Target, 5 years ago, actually, that .com group bought our solution, which is service virtualization solution, just for the purpose of the performance testing. Long time ago, but there was a use case.
Yeah. In smaller chunks, yes, you're
Yeah.
very right, because it takes a lot of effort to process the entire.
Right. And the good thing about this is that you can do it part of your CI/CD pipeline. So imagine like overnight you're running your performance test. So you're seeing if somebody checked in the code that completely slowed down the system, there's probably some SQL query or whatnot that is not optimal. You see it on a bump right away overnight. You don't wait until the last second to do your overall big shebang of performance test.
And you can use it to predict things that you don't think about during normal testing.
Yeah.
Like you're getting the response that you expect from this service, whether internal or external, but it's taking twice or 3 times as long. It's something you could set up a simulator to just add to your regular testing down the road, where you might not think of it when everything's running smoothly.
Yep.
All right, let's speed up. Now, how is it applicable to IoT? I do have some pretty pictures, but the concept is the same. Divide and conquer. So you would test the integration layer. Let's say you would test the gateway, and some artifacts in the cloud. Maybe it's a third-party service, or maybe it's just your own internal API. Right, so you define your IoT application under test as a gateway and some services in the back end. Okay, so you define it and you start testing them in isolation. You would then inject maybe some MQ events into your broker, right? So that will then in turn call the cloud. The cloud will call other things. Maybe the mobile will also inject some events into the gateway, blah, blah, blah. So we got this whole system kind of tested. However, what happens then on the back end, there are some dependencies, maybe third-party API, that are not accessible. So with virtual services, you can then create yourself a test environment that will stand up those services on demand, and it's easier to integrate into the CD pipeline. Another concept, it's validation. So when we run the end, let's say component level test, API level test, we also like to, and that transaction follows few steps. Let's say it goes from a gateway to an API, then to another API, then some mainframe gets updated, some database gets updated, and that's my component that I'm testing. Then a lot of times you want to make sure that the workflow, how the data flows through your ecosystem is also verified. So you put some proxies or some monitors in all stages of that transformation of your packet so that you can validate it later. So you kind of store that in logs or ping the database if the records have been updated correctly. So there are a lot of things you can do to validate your transaction. Okay? And that brings us to the topic of DevOps, testing on demand. The virtual services, or those mocks, allow you to quickly stand up your test in the cloud, right? So here, when you check in, build around your unit test, we already passed that point. You deploy application here on a public or private cloud server, let's say on Azure or AWS. Then you deploy it in, let's say, Docker container. And then what you can do on the fly, now that you don't need the mainframe in the backend, you don't necessarily need the entire database. You just stand up those little things that will respond enough to get your test case pass or fail. So they have enough intelligence to respond properly to this test case. And then you deploy some others. So the rule of the game is divide and conquer. And then once you divide them in smaller pieces, you can check them into the repository. And Jenkins will check them out, provision them correctly, and you run your automated functional and performance tests on demand, which is right there. Okay? Has little to do with IoT. It's just the regular enterprise-level testing concepts. Okay? In our example, those would be the services that I would kind of stand up. One is something that will inject or be a service as a user, so you can inject things here. And the test here, the test will inject things in the MQTT broker, and the infotainment will be the application under test. Okay? We're switching topics now, so this is the end of the virtual services idea. We're going to go to the API simulators now. It's a small topic, API simulators, but any questions on the virtual services? Kind of went very fast. Okay, so we have 9 minutes left. I wanted to show you one cool thing, which is the car simulator by Mercedes-Benz, by Daimler. Oh, before I go there, I think this slide makes sense. So here's the trend that I see. People, once they become part of the IoT ecosystem, other people potentially create devices, create modules or applications, potentially mobile applications, to run against that API. So that's a trend, right? So in that trend, how does the market respond? They provide development kits that include API simulator. That's it. That's the point of this slide. I'm going to show you. So this is a simulator by Daimler. I did this yesterday, so I just logged in. If you know this URL, you log in, you create your own account there, and you can do what I do right now. Even though Daimler is our client, but this is publicly accessible API. So what I can do is, look, I can open the door, I can lock the door. So I can pretend that I am going to do certain things to the car. So let's say I can charge. So I can say battery level, diagnostics. So let's say fuel level. I already play with that, so I make the car empty. But yeah, you can probably load it up with some fuel. Doors in my simulation will be, front will be unlocked. So I'm just, creating the scenario for the car to respond the way it is. So just by me creating a state of the car that I need for my application now. Let's say I'm like an insurance guy, right? So an insurance company, let's say Progressive, developed an application to make sure that during the normal operation of a car, all of the doors are locked. Maybe it's a valid application. So I want to make sure that you're driving the car safely, okay? So as a developer, I would use that API to develop my own. So it's a real API right now, and the cars, Mercedes-Benz, are developing this API right now. So the car will actually talk REST. And then here, I can go and start the simulation. So where is it? So start simulation, create, Andrey sim, okay? And now I can add the capability, let's say charging, battery level, boom, and at the point, and the battery level is going to be rapidly depleting, okay? So that's my simulation. I can replay that simulation, boom, boom, boom. See, the time is moving. My battery is now depleting. There's a log. So if my application is monitoring the charge of my battery, the car will respond appropriately, okay? Same thing I can do here to add, not only my battery is now depleting, but I'm losing fuel. So here I had 60%, and in the next 5 seconds, I will lose, let's say, a lot of fuel, right? So I can now replay that simulator and develop my application against that scenario, okay? All right, so that was an example of API simulator that are now being a standard offering by the API providers. And that is relevant to IoT, for sure, because that trend did not exist before. Okay? Yes.
Another way of doing it, you can record real car data and replay.
Yes, you can do it. We actually, that's one of our offerings do that. But the problem is you have to have a real car. You don't have money to buy Mercedes, I know that. Yeah, because you spend all your money on the...
But Mercedes or any other API provider of an API simulator, they have that real car data. They could provide a set of here's a car that, under normal conditions at such and such, or like, here's a car, 5 minutes until it crashes. Yeah. Like, here's all the data we got.
Yes. Yes. They do provide that packages. So what we wanted to work with, what we wanted to do with them, not me, but our company, is to sort of give user the ability to change the data on the backend. So right now it's pretty preset, right? I cannot go in there and say, hey, I want that to respond with certain data. It's just all of the data there is predetermined by the knobs that I have. what if I want to add my own knob? You know, so that's where we come in. All right, couple of things about IoT platform and enterprise testing. More protocols are being now introduced in the IoT space. Interoperability is the key between dev and QA. Now I'm seeing the trend that QAs are no longer a profession. It's either developer who does testing. So a lot of QAs are now becoming a lot more technical, a lot more scripty, a lot more programming. Safety and performance is important. Run early, end-to-end testing. Sure, you combine different protocols, and then you create a scenario to ping database, to ping an API, to ping a synchronous or asynchronous protocol. So the challenge is to how do you create a test, one scenario, that can talk across all those multiple domains and multiple protocols. That's the challenge, right? And integration with DevOps, test early and often. So key takeaways from this very quick API and enterprise testing lecture is you want to focus on API testing. But when you create APIs, please make them stateless. Please make them simple. There's this whole notion of microservices that I think will be taught in January. So there's January talk, or it was taught. So microservice is a big thing. It has, in my opinion, nothing to do with IoT. Yes, IoT makes the microservices more important, but it's not specific to IoT. I think microservices have become a thing before the IoT boom started. So create reusable services to isolate component under test. The key is to create them reusable. So let's say if I'm a developer, I created something, I give to my tester and say, hey, use this fake data, fake virtual service to test at your level now. So define who owns the API testing domain. That's a cultural thing, right? So perform security and pen testing earlier. Integrate with CI/CD. We are running against the time, 11 o'clock. So there are some slides here that I've created to see what are the similarities between embedded and enterprise IT. So now, since embedded has certain properties, like it was here, embedded development has focus on prevention, do compliance, do coding standards, do unit testing, minimize testing fully integrated systems because it's just very, very expensive, focusing on compliance, not speed. So it's very like a waterfall-y development, right? And then the enterprise IT development, they're agile, embracing agile. Let's do quick iteration. Let's make sure that every time, every day, we can release the product, minimally viable product, right? That's agile. You want to go fast. You want to deliver on certain, you talk sprints, you talk minimally viable products. So it's a different culture, right? So what I'm seeing right now, when those embedded guys start talking to the agile guys, they don't understand each other at all. So how do you make that trend? You got to have to meet in the middle, and that's a trend specific to IoT. I got a question from a guy said, well, when I tell them that the safety is going to take 2 years, they laugh at me because they can develop the website in a matter of seconds. They can provision the website in a matter of seconds, right? So when they say, no, we kind of need 2 years to develop a prototype of this hardware component that will run the robot, it's a big cultural shock for both sides of the house. All right, we covered those 3 areas. Development testing, we talked about static analysis. Unit testing, we talked about API testing. We talked about the importance of integration in CI/CD pipeline. Okay, as a wrap-up, key takeaway, if anything in those 3 hours that I want you to take away with is prepare for compliance when you're developing your either embedded applications or IT applications, think about compliance potentially down the road. Focus on creating clean and simple testable APIs. Please, whoever developing API, I know that there are some developers here in the room, please don't put a state in the API because it's harder to test. Creating a stateful tests is a maintenance nightmare. So API testing is the key. So the cleaner the APIs, the more standardized testing you can do in your organizations. You can decouple the components quicker, and that's the rule of the game here. That's how you go fast. Everything else, also important, but I would focus on those 3 key takeaways from this talk. Yes?
I promised that question. I can't help but see how the entire IoT stack doesn't become mission critical in certain, or safety critical in certain applications. Like we have somebody who's working on infusion pumps, and now Epic can actually send the prescription to the pump from the doctor.
Yeah.
So if something goes wrong in Epic, you could kill somebody. Do you see these standards and compliance things that you have to take into account from the edge level start moving up the stack?
Yes, I don't see it right now, personally, because I'm not in the room where the standards are being created. But I sense with every cell of my body that will happen. I totally agree with you that the standards are all outdated. Could we turn off the camera? Sometimes stupid. And I think they will change to eliminate some of the things overhead that modern compilers, modern languages already taking care of. So the standards will become thinner in some part and thicker in other parts. Like API testing will become more important and more controlled by the standards than they are right now. I agree.
Yes.
Isn't making API stateless kind of unrealistic or embedded? I mean, take for example, streaming versus just communicating packets. It's a state. Embedded machines are complex systems of state machines.
So you embed, we can talk about that later after the talk, but yes, you're right. Embedded device is naturally stateful. There is a state embedded, but you can design your API so that you can test that API and inject the state into the system, right? So there are ways to get around that problem. So API can have a notion of I'm in this state. So from the test layer, you can say, move to this state or pretend that you're there. And when you get in the responses from the API, it can also give you a hint which state you're in. So your test doesn't have to have 30 steps of setup logic to hopefully get to the freaking state that it's in. Make sense? Yeah. So yes, you're right, but there are ways to get around it. Okay. This is what we do. I promised Mike that I will not spend more than 10 minutes on Parasoft. That's our offering. We basically create and sell tools to help people automate software testing in all of those domains. Starting from static analysis, unit testing, code coverage, API testing, service virtualization, load and performance testing, reporting, and analytics. So we focus on the end-to-end testing. We have strategic ecosystems. Everything I talked to you about today are snapshots or snippets of conversations with real customers that we have or real prospects. So you're basically getting some realistic data from sample of people from across the United States and the world. That's it.